Now here, let's figure out what is required. In this figure, ABCDE is a pentagon, so we can clearly see the pentagon ABCDE and the lines GE, AD are parallel and BD, CF are parallel. We have to show that the area of this pentagon is equal to the area of this triangle GDF. Now for that, we just want you to think how we can get things going between the parallel lines. So the concept where you need to be more watchful is that's what's happening between CFDB and DAEG. Right? In the next part, we'll show you what are the exact steps of the proof. Alright. Sorry about the extra color. Please don't mind. We've got it a bit colorful so that you can distinguish between the parts where we need to concentrate. Of course, it's a very simple proof, so I won't complicate it. It's based on the 3 steps, 1, 2 and 3, very direct. Step number 1, on this side, carefully see, on this side we are working on the triangles, and there are 3 triangles which make the pentagon. They are this red cross triangle AED, this blue triangle, and finally this BCD, the other red cross triangle. So we have the red triangle, blue and the red triangle which make the pentagon. Alright, basically area theorems are more visual. You need to see the triangles, the shapes, and on the basis of that you need to figure out which shapes to exactly select for the adequate proof. It's not about learning. You don't need to learn these things. Actually, you can't. Now, on this side, we have the triangles. The 3 triangles which make the big triangle. The big triangle GDF. And which are the triangles? The green dots, the blue shaded part, and again the green dots. Now, we divide it into 3 simple parts. Part 1 is related to this trapezium. Of course, GEDA is a trapezium, and this trapezium we can see that the 2 triangles AED and AGD have the same base AD and lie between the same parallels. Therefore, AED and AGD are equal in area. So we have here this triangle, that's the red triangle, and the green triangle. They are equal in area. Now, coming to this side trapezium, we have BCD equal in area to BDF. Why? Again the same reason, they have the same base DB and lie between the same parallels. Fine? Finally, DAB happens to be the common part. So that ADB is simply added to both. Of course, I did not mention the reasons to this proof. First and second reason are same. That is, triangles having the same base and lying between the same parallels are equal in area. And then the third part, the reason is simple, that this part is common. Now all you need to do is add 1, 2 and 3. Once you add them, you get the red triangles and the blue part, which together make the pentagon ABCDE. And then we have these 2 green triangles and the blue part, which is common, that makes the main triangle GDF. Now let's see, we were to prove that area pentagon ABCDE is equal to triangle DGF. So we have proved that the pentagon ABCDE is equal to triangle DGF in terms of area.